Hello, we have a question here in the treat today. This question is on modular arithmetic. So we are required to draw a multiplication table for the arithmetic modulo 7. And that's the A part. The B part, we are to use the table we have drawn. And first of all, we will state reasons whether or not the operation is commutative. And then secondly, we are going to evaluate for modulo 6, modulo 5, modulo 4, and we'll find the truth set. Finally, we'll find the truth set of n modulo n equal to n. Okay, we'll go through this and I'll explain what they mean. It's not difficult at all. Okay, so first of all, let's draw the multiplication table of modulo 7. Okay, so you know, modulo is just about remainders. That's basically what it is. It's about remainders. So when we talk about the set of numbers in modulo 7, we have 1, 2, 3, 4, 5, 6. Of course, 0 is there. So you can have no remainder at all. So 0, 1, 2, 3, 4, 5, 6, just like this. Okay, why do we have this? Let me explain. For example, if I have 14 and I'm dividing it by 7, it's going to give me 2 remainder 0, hence the 0. And if I have 15 divided by 7, it gives me still 2 remainder 1, hence this 1. If I have 16 divided by 7, it gives me 2 remainder 2, hence this 2. I have something like 17 divided by 7, it will give me 2 remainder 3, hence this 3. I have 18 divided by 7 to give me 2 remainder what? 4. That's correct. 2 remainder 4. Okay. So subsequently 19 divided by 7, that will give us 2 remainder 5. 20 divided by 7 will give us 2 remainder 6. But 21 divided by 7 will give us 3 remainder 0. So you see, you can't give us 7. You can't have a remainder of 7 when you're working in modulo 7. You only have numbers below it and 0. So you can have a remainder of 0, 1, 2, 3, 4, 5, 6. You can't have 7. Okay. So now, in order to do that, do the multiplication. Let me get rid of this. Oh, sorry about that. Let me get rid of this so we can now do the multiplication. Having explained how we got that. So in order to do this multiplication now, we're going to draw a table or something like this. Since it's 0 to 6, something like, let me say here. This place will show us that we're multiplying, and the numbers will tell us the modulo. So since it's modulo 7, 0, 1, 2, 3, 4, 5, and 6. On this side, 0, 1, 2, 3, 4, 5, and 6. And this, we have this, okay, and on this side. Please forgive me for my crooked lines. Manage them. Alright, so we have this. Okay, so we have a table like this. Now this is showing that we're multiplying. So it's just simple, we just begin to multiply. When we get a number less than 7, we're going to write it. When we get a number more than 7, we will now write the remainder. We will divide and write the remainder. Okay. The first rule, 0 times 0 is 0, so it's less than 7, we'll write it. 0 times 1, that's 0, it's less than 7, so we'll write it. 0 times 2 is still 0, less than 7, we'll write it. 0 times 3 is still 0, less than 7, we'll write it. 0 times 4 is still 0, less than 7, we'll write it. 0 times 5 is still 0, less than 7, we'll write it. And 0 times 6, still 0, less than 7, we'll write it. So the first rule is just zeros. Okay. Now the second one, 1 times 0, that's 0. Still less than 7, so I'll write it. 1 times 1, that's 1. Still less than 7, I'll write it. 1 times 2, that's 2. Still less than 7, I'll write it. 1 times 3, that's 3. Still less than 7, so I'll write it. 1 times 4, yeah, that's definitely 4. 4 is less than 7, so I'll write 4. 1 times 5, that's 5. 5 is less than 7, so we'll write it. And 1 times 6, that's 6. 6 is less than 7, so we'll write 6. So I hope you're understanding so far. It's a very simple process. Okay, let's continue. So moving to 2 now. So 2 times 0, that's the 0. And I've written 0 because it's less than 7. 2 times 1, still 2. Less than 7, so I write 2. 2 times 2, that's 4. Less than 7, so I still write 4. 2 times 3, 6. Less than 7, so I write it. But 2 times 4 gives us 8. So we have finally arrived at a number bigger than 7. So we can write 8. So what we'll do is to come here and divide 8 by 7. Of course, this will give us 1 remainder 1. So is this remainder 1 we'll write. So I write 1 here. So I write 1 here. Then 2 times 5. That gives us 10. So I divide it by 7 again. This will give me 1 remainder 3. So this remainder 3 I'll write. So I'll write 3 here. And of course, 2 times 6 is 12. So for that, I'll write 12 and I'll divide it by 7. And this will give me 1. Remember what? Yeah, 5, definitely. 1 remainder 5. So instead of writing 1, we'll write the remainder as usual. So I'll write 5 here. Okay. So that's that. So now let's go to 3. Let's go to 3. So 3 times 0, 0. 3 times 1, 3. Of course, these are less than 7. That's why I'm writing them. 3 times 2, 6. Still less than 7, so I'll write it. 3 times 3, 9. So I can write 9. I'll divide by 7. So it gives me 1 remainder 2. So I'll write this remainder 2. Next is 3 times 4, which is 12. We've done 12 before, but I'll just show it again. 12 divided by 7, that's 1 remainder 5. So I'll write remainder 5. Then next will be 3 times 5, which is 15. So 15 divided by 7, this is 2 remainder 1. So I'll write 1. And then 3 times 6, that's 18. So 18 divided by 7, I think this is 2 remainder 4. Because 14 plus 4 will give us 18. So I'll write 4. So we are done with the third row. Now let's go to 4. So 4 times 0, 0. 4 times 1, 4. Again, I'm writing them because they are less than 7. But 4 times 2 is more than 7, it's 8. 8 divided by 7, that's 1 remainder 1. So I'll write the remainder 1. 4 times 3 is 12. We've done 12 several times, but let me do it again. So 7 and 12 will go 1 time, and the remainder is 5. So I'll write 5. So let's go. Then 4 times 4, that gives us 16. 16 divided by 7 will give us 2 remainder 2. But then 14 plus 2 will give you 16. So here's the remainder 2. I'll write that remainder 2. Not this 2, I'm writing the remainder 2. Okay. Then next, 4 times 5, that's 20. So 20 divided by 7, I think this is 2 and 6 this time. So I'll write remainder 6. So I'll write 6 here. And then we go to the next, which is 4 times 6. That's 24. So 24 divided by 7. This will give us 3 remainder 3. Yeah, plus 21 plus 3 will give us 24. And so for this, you need to be conversant with your division. the multiplication and division, you need to be, if you're not conversant with them, you'll be slow and you may make mistakes. And once you make a mistake in the table, it may affect your calculations later. So it's good you take your time, you should know exactly what you're multiplying and dividing, be sure they're correct. So once again, we'll write remainder, so remainder 3. So we're going to 5 now. Excuse me. Okay, so we're going to 5. So 5 times 0 plus 0, 5 times 1 is still less than 7, so 5. But 5 times 2 is 10. So 10 divided by 7, that's 1 remainder 3. So I'll write the remainder 3. 5 times 3 is 15. 15 divided by 7 is 2 remainder 1. So I'll write remainder 1. And 5 times 4 is 20. 20 divided by 7 is 2 remainder 6. So I'll write remainder 6. And next is 5 times 6. Okay, 5 times 5, please. 5 times 5. Yeah. That gives us 25. 25 divided by 7 is definitely 3 remainder 4. Because 21 plus 4 is 25. So I write remainder 4 here. And finally, we have 5 times 6. Let's clean here, show that. So 5 times 5 times 6. Let's come here. So that will be 5 times 6 is 30. So 30 divided by 7, that will be 7 here is 4. That's 28. So remember 2. So we write 2 here. Okay, so we are down to the last row now. Okay, so 6 times 0, definitely 0. 6 times 1, 6. I'm writing them because they are less than 7. 6 times 2, that's 12. 12 divided by 7 is 1 remainder 5. So 5 comes here. 6 times 3 is 18. 18 divided by 7 is 2 remainder 5. No, 2 remainder 4. Yeah. Because 14 plus 4 will give you 18. So 4. And then we have 6 times 4 now, which is 24 divided by 7. This will give us 3 remainder 3. 21 plus 3 definitely 24, so remainder 3. We still have 2 more columns to go. So 6 times 5, 6 times 5 comes in 30. So 30 divided by 7, this will give 4 remainder 2. So I write 2 here for the remainder. I'm not going to write the whole number, it's the remainder I'll write. And then the last one, which is 6 times 6 for here. That's 36. So we're not going to write 36, we'll write 36 divided by 7. This one is going to give us 5 remainder 1 because 5 times 7 is 35. And this one gives you 36. So the remainder is 1. So I'll write 1 here. So this is the A part. This is the A part. This is the table in module 7. So this one. Okay, I hope you understood this. So let's proceed. So then take your time, rewind the video, look through it again to understand it properly. Okay, so we'll leave it just for a few seconds and then I'll clean it so that we can go to the B part because I don't want to clean the question itself. Okay, so the time, and your time is up, so you have to clean it. Okay, but I need the table, so I think I have to go back on what I said. I'll use here. And I think I will erase the parts of the question I've done before instead. So let's continue here because I'll need the table. So B says, using the table, state the reasons whether or not the operation multiplication is commutative. So for something to be commutative, the law states that A times B should be equal to B times A. For example, if A is 5 and B is 4, 5 times 4 is definitely equal to 4 times 5. This is the law, this is the commutative law. Now, let's check if it applies. So we'll use a couple. So for example, let's use 4 modulo 3 in multiplication and see if it will equal 3 modulo 4. If it does, then it's commutative on that multiplication. Okay, so I'm going to click here. So we continue here. Okay, so now let's check 4 modulo 3. 4 modulo 3 as when you're multiplying modulo 7. So what does that give us? We have to come down all the way to here. That's 5. So 4 is equal to 5, right? Now let's check 1. 3 times 4. In modulo 7 we use 3 times 4. That's to give us 5. So 3 is still equal to 5. So see them. 4 times 3. It's 4 and 3. So both of them will meet at this point. And 3 times 4. So both of them will meet at this point. So both give us 5. This means that 4 modulo 3 in modulo 7 is equal to 3 times 4. Okay. So what this means is that, yes, it's commutative. And it's commutative because if you exchange the numbers and you check the table, they give you the same value. That's the reason. If you exchange, like I told you what the law of the commutative law states, that A times B is going to be equal to B times A. So it's all about switching positions. So you see, if you switch the position that we have here to what we have here, it still gives us 5 and 5. So therefore, yes, it's commutative. So that's the B part. Okay, now in the C part. Not the C part, that's the BI part. Sorry. So to the II part, it says we should evaluate 4 times 6 times 5 times 4. Okay, this looks complicated, but with the table it's not. So I'm going to clean this part. So we keep working. So the answer is yes. It is commutative because it obeys the commutative law. As seen using so you can use yours, please. This thing is not just only 4 times 3 and 3 times 4 that work. If you check something like 5 times 3, will give you 1. I'm sure if you check 3 times 5, still give you 1. So you can use any one. Okay, so now to the second part, see we should evaluate this. So this is BI, now we're in BII. So you say we should evaluate this. So you take it step by step. The first you evaluate this. So let's see what 4 times 6 in modulo 7 will give us. So check that. 4 times 6. 3 6. So one of the meet here are 3. This is 6. This is 4. So the answer will be 3. So 4 times 6 is 3. Then check what 5 times 4 will give you. So 5 times 4 in the meet here. Okay. 5 times 4 they meet here. So you just have to be careful. So that's 6. So 5 times 4 is 6. So automatically I can replace 4 times 6 with 3. Then this is my multiplication. And then I can also replace 5 times 4 with 6. So I've broken it down. So let me explain what I did again. I simplify this to give us 3 from the table. Simplify this to give us 6 from the table. Then I replaced 4 times 6 with 3 and replaced 5 times 4 with 6. This is the times in between them. Okay. So at this stage now we have 3 times 6. We will still go back to the table. It's all about the table. So go back to the table. 3 times 6. That's it. So that's 4. So the answer to this is 4. Okay, we must cycle this to be confusing. So the answer is 4. That's just BII. That's simple. So you see, if you look at this question initially, it look big, difficult, but actually it's not. Just all about simple division and multiplication. Then the last part, It says we should find the truth set for n times n. Now, a set simply means collection of elements written in this shape. So, for example, if I have a set of alphabets, so let me say set of vowels would be A, E, I, O. So I've written a set of vowels. Now, they want us to write a set that suffices this condition, or maybe another word, obeys this condition. Now, this condition, what is trying to tell us? Trying to tell us when n multiplies n, you should get n. So what it means is, like, for example, look at this. 0 multiplies 0, give you 0. So you obey that condition. You look at another thing like 1 multiplies 1, give you 1. So also obeys that condition. So you just look around the table and then you get the element. So let's check. Let's start. So 0 times 0. So you write I here. So in my set, I'm going to put 0 first because 0 obeys it. 0 times 0 gave me 0. 1 times 1 gave me 1. So 1. But 2 times 2 didn't give me 2. It gave me 4. So no. 3 times 3 gave me 2. So no. 4 times 4 gave me 2. So no. And 5 times 5 gave me what? 4. It's supposed to give me 5 if it's correct. So no. And finally, 6 times 6 gave me 1 instead of 6. So these are the only elements in that set. 0 and 1. They're the only ones that when you multiply them, you still get the number back. Hope that's clear enough. So that's that. So we've gone through all the questions, we provided the solutions. You could solve similar questions to this using the idea here. Thank you so much for your time. God bless you. I'll see you next time.
Oh, I used to clap for you.